Hi, hello, vanakkam, and welcome back to yet another episode on your favorite Little Slaw YouTube channel. So today in this video, we are going to see about what is a pod, what are the key concept of pods, and what does a pod contain. So we normally know a pod contains a container. So we'll see what is a container and how does it stay inside the pod, and we'll see its nature. We'll see the life cycle of the pod, and also we'll see why do we need pods? Why do we need pods in containers, the Kubernetes, and we'll also see some examples, some real use cases on why do we need pods. And before we move on to this video, this is me, Asan Shanmugam. So please don't forget to subscribe to our channel if you haven't subscribed it yet. And like I told you, we are today in the day 5, day 6 of the Kubernetes training. So like I told you, if you join with me for the next 100 days, you will be an expert in Kubernetes. So you can attend your certifications, you can clear certifications for Kubernetes, or even you can get a good job. But the thing is, like, you have to keep on practicing with me. You have to keep following me my videos on Kubernetes, and you have to practice the end to end whatever I'm trying here. And yeah, so please don't forget to subscribe to the channel if you haven't joined the channel yet. Please to join the channel for more trainings and for more information like this. And like the video if you really like this, and share the video with your friends who are training for Kubernetes uh, trainings. So before let's move on to the video. So let's do Kubernetes start, and we are in the video. We are in the lens now. So going forward, I'll use more of a lens because that's what you're going to use in your organizations as well. So please use lens for any configurations, for any application monitoring. And again, I have told you why do you need to use lens. So please do use lens for the configuration for monitoring, and even you can use the terminal here to do all these commands and running it. So first thing is, so now we all know a pod contains a container, right? So basically, what is a pod? So here we see we have a pod. So this is the pods. We have 3 pods running, and I have restarted it twice because every time I wanted to demo, I start it and then at the end of the demo I stop it. So these restarts are the time which I stop it at the end, and then when I do a start, so automatically it gets restarted. So that's the reason you can see restart twice. And the reason I'm telling you here is when you were monitoring your pods in real time, so you have to make sure that did they get restarted, and if they really get it restarted, so you need to find like when it get restarted and why does it get restarted, because sometimes if it needs restart, then you can also do a restart um, to make it up and running. And now let me explain you about pod. So pod is the smallest and the simplest unit in the Kubernetes, which we all know, and you can create, which you can create. I mean, the pods you can create or deploy. So it represents a single instance of running process in your cluster. So by understanding pod and how it works, the fundamentals, you can use your Kubernetes effectively. So pod will contain one or more containers. So pod can contain one or more containers, usually Docker containers. So containers in a pod share the same network namespace. They can communicate with each other, and they also share the same storage volumes like we did here. So all these pods share the same storage volumes, and the containers inside the pods also share the same storage volumes. So to see the pod, so to see the container, so I told you the pod contains the container. So here I can show you the pod, but where does the container is? So where does the container sits in, or like what does it do? So here in this properties, you can see the metrics. You can see the CPU and memory, and then you can see when it is getting when it was created, and the name of the pod, the namespace of it, and the labels, and it's controlled by, and what is the current status of it. So we're all going to see about that. And for now I will show you the containers part. So here if you see, the nginx is the container which is running inside the pod, and it has just only one container. So in fact I will show you how to run multiple containers inside a pod, but for now this particular pod, I mean, like, each pod contains one container, and that's a nginx container. And you can also see the status of the container as well. It's running and ready. The last status, yes, it was terminated, and the reason is I have told you, I wanted to stop it before I after I end my demo. And now we can see more details about it. So let me show you how to do that. And also it's more important for you to learn the um commands as well, because that will help you to firstly to clear interviews, and it will also help you to understand the, I mean, like, to learn more about the Kubernetes. So firstly, let me show type the command, which is kubectl describe pod, and then let me copy this pod name here. Yep. So this will show me the details of the pod. So here you can see the name of this particular pod, the namespace, which you already see in the property section, and this one has different IPs. Yes, each pod has different IPs. And yeah, that anyways, I'll deal with that in a separate topic. But for now, yeah, it has a separate IP, and then it is controlled by this particular replica set nginx deployment, and it has this container, the container ID, it has it here. And the image which I'm using is the nginx image, and this is where I have pulled the image ID. And it does not have any port, or it does not have any co-host port. And the state of it is currently running, and the last state is terminated. Because I have terminated it, I have stopped it um, after I entered the demo, the previous demo, and it was started just now. It was finished previously, like it was finished previously after the demo, and the restart count is 2. So I have to restart it twice so far. So when you watch this the next time, there will be like 3 restarts, because I will stop it now and then we'll restart after for the next demo. So this is how you can understand the container. So for now, like I told you, so a pod will contain multiple containers. So just remember, because you might get this question. So, and we might get confused. So we need to understand that a container does not have a pod, but a pod will have the container, and a pod will have one or more containers. Yes, you're right. And now the next part about the pod. So every pod will have single IP address, because each pod will be assigned a unique IP address within the Kubernetes cluster. Because if you see the first one, the IP of the first pod is ends in 17. The second one is 16. The third one is 18. So each pod has its own IP address, and all containers in a pod, all containers, like I said, the nginx containers, right? If I have multiple containers, all those containers in a pod share the same network IP and can communicate with each other using localhost. From outside, the pod can be accessed using its IP address. So if you want to access this particular container, see, let me just try that. So now when I try to access the IP, the pod IP, I'm not able to access it. So the reason is the IP is not exposed. So we'll have to expose it. And for that, I'm going to use kubectl expose the pod and then the nginx deployment. Okay, let me just copy this. So this is the one which I want to expose it now. So let me just copy this here. So the nginx deployment, I'm going to expose this particular pod, and the type of it is node port, and the port number is 80, and then the target port. So we have to, because if you see here, we do not have a port, or we do not have a host port. So I'm going to add that. I'm going to give that port now. And then the target minus port equals 80. And then the name equals nginx service. That's a service which we want to expose. So now the service, or the nginx service, has been created. It's been exposed. So now when I type kubectl get service nginx minus service. So yep, now I have got a cluster IP, and then I have got a port as well, and that's a TCP port. So this is the node port which is assigned by Kubernetes, and we can access the nginx server at node. The node IP. So where do we have the node IP? Yep. So what I'm going to do is, let me open a browser and let's open it. Let's access it. So as mentioned here, I'm going to give the IP. So it's going to be HTTP colon, and the node IP is 10.109.89.150 colon. The port number is 30398. or I think I should access the node IP. Okay, let's try this one. Okay, I think this is the IP which I want to try. So that is 10.244.0.17. So now you can see I have configured the local host 8081, which is with the current Nginx, and then you can see the Nginx is running now. And yeah, we took several steps, but I'll explain you in the upcoming videos. But for now, yes, I'm able to execute this service, because if you see here, I have forwarded the connection to the port, which is 8081. So I'm able to access. So if you see, I'm forwarding from the localhost 8081 port, and I'm able to see the connection. So now the next part is, so far we saw about the single IP address, and we will see about the shared storage. So containers in the pod can access the shared storage volumes, which allow them to process data or share data between containers. So we'll see them in the upcoming videos. But now, for now, this shared storage is typically mounted into containers file systems. And next part is about the pods. So this has the ephemeral nature. So what is ephemeral nature? Because pods are considered ephemeral, meaning they are not meant to be durable or long lived. But I would say it will long live. But again, in this term, I mean, like for explaining it to you, I'm telling you that they are not meant to be durable or long lived. But if a pod dies, or if a container get crashes inside the pod, the Kubernetes can replace it with a new pod, but it will be treated as a new instance with a new IP address, right? So that's the reason we call it as ephemeral, which means we cannot say that it is not we cannot say that it is a durable one, right? So it is not meant to be durable. It is durable, but here in terms of Kubernetes, we are making it that it is not durable, because if something happens, if some containers crashes, or if the pod dies, the Kubernetes will automatically replace it with a new instance with a new IP address. And then when it comes to the pod lifecycle, so here you can see the current state of it is running. So, like I mentioned, the other status or the other phases of this pod is, it will be in a pending status, because while it is getting created, it will be in a pending status, and then while it is running, it will be in running status, and then while it has succeeded, I mean, when it is successfully created, it will be in a succeeded status. And then if something goes wrong, and if the pod gets failed, then it will be in a failed status. And then if the pod is not known, or if it is in an unknown condition, so the pod will turn to be unknown. So we'll see them one by one in a separate video. Like, I will take you through a demo on, I'll change it to a different life cycle of the pod. So the next part is the pod template. So when we are using higher level controls like deployments or stateful sets, we typically don't create pods directly like we do here. So instead, we define a pod template which specify how to create the pods. So the controller then manages the pods based on that template, right? So that's again, I will see how to see, or how to create the pods using the templates as well. And then finally, the single process or application. So while you can run multiple containers in a pod, it is generally recommended that a pod runs a single main application, because this follows the single responsibility principle, where each pod does one thing well. So that's all about the pods. And why pods? So pods encapsulate one or more containers. Like I told you, it has one or more containers, and they have a shared storage and the networking resources into a single unit of deployment. And this abstraction allows the Kubernetes to manage lifecycle of a container as a single entity. And when it comes to consistency, so when you are, so here we are grouping the containers, so that needs to work together in a pod. Kubernetes ensures they are always scheduled together on the same node and can communicate efficiently. So that's the reason we do use pods for the encapsulation, for the consistency, and finally for scaling. So here you can see I have scaled from one pod to three pods, and we can easily scale our application by creating multiple copies of a pod, and this makes it straightforward to scale out application that require horizontal scaling. And when it comes to the use cases, a pod might run a microservice along with a logging or monitoring containers as a side case, so which allows the main application to focus on its core functionality, while the side case handles tasks like logging. And then the front end and back end. For a simple web application, you could have one pod running both the front end and back end containers, although it's more common to separate these into different pods for scalability and management purposes. So overall, in a summary, I'll have to tell about the pods. A pod in Kubernetes is a fundamental building block that helps encapsulate your application and its dependencies, ensuring they are deployed and managed as a single unit. So if you understand pods, you very well know that it's very crucial for effectively managing the containerized applications within a Kubernetes environment. So until we meet in our next video, it's bye bye from Mr. Mugam and your favorite Little Slaw YouTube channel. Take care and bye bye.